But why have we evolved to have this real passionate love of music? And then as a memory scientist, why is it that those memories are so powerful? Why is it that you only need to hear a tiny bit of a song or even just see the title of a song to be completely thrown back to a particular moment in your life?
Hello and welcome to Different Conversations, where every week we have a different academic from the College of Liberal Arts and Sciences at the University of Westminster in to talk about their work, their research, their interests, and what is, well, along with the title, new, interesting and different. This week I've got my good friend, my colleague, Professor Catherine Loveday from the School of Social Sciences. Catherine, how are we doing today?
I'm good, thanks. Really happy to be here.
And we're super happy to have you along. Because we've met before, we've talked a lot about work. We overlap a little bit in our work into aging, into how humans age, how we deal with aging. But your work specifically, I find so interesting and so topical and applicable. But before we even get there, one of the reasons I wanted to have you in is just to introduce some of the work you're doing. So if you had to give an elevator pitch to the world to tell us who you were, what kind of things would describe who Catherine is?
Gosh, that's a big question. I am fascinated by human beings. I guess that's why I do what I do, but I'm particularly fascinated by people's stories. And I started off as a very experimental memory scientist, giving people lists of words to learn. And then I kind of crept into what we call autobiographical memory, which is your memory for your life. And it's so fascinating. Basically, what I get to do for my research is to get to listen to people's stories and to then do the science behind why they've remembered those things, what they mean, and what's going on in the brain when people remember them. So I guess I would see myself primarily as a memory scientist. But I'm also a musician. So a lot of my work nowadays touches on music and on musical memories. And my PhD was on aging, as you mentioned. And so I have this long standing sort of fascination really with the whole lifespan. So I've looked at adolescence over time and I've looked at sort of older age over time. And I'm just really interested in how the brain changes over that time, but also how we remember different things from different periods of our life. And that's really kind of where I am now, is trying to understand that and understand what's going on in our brain when we do that.
And I love that quote. I love that quote so much. I'm fascinated by people because I think that's why we talk about research. We get along so well. Is that's my kind of driving ethos as well as a research scientist. I try not to bring my science life into this podcast too much. I try and be an unbiased interviewer, but people are fascinating. And you've approached it from this very cognitive way, this neuroscience way, this memory type of way. Mine's always been more physical, I think. But this is how I know you. I know you as a person who specializes in the brain over life course. And that's one of the reasons I wanted to have you on today, was you've written quite a successful book about this, The Secret World of the Brain. What inspired that?
Yeah, I guess I was teaching this stuff to first years, and I was teaching a whole range of things about what goes on in the brain, and the students loved it. But then I did that thing of sort of talking to my friends in the pub about it, and then I started doing a bit more public engagement, and I thought, actually, there really isn't anything out there that sort of tells the story and looks at all these different aspects of brain function in a, I think, sort of hopefully appealing way. And really what I sort of set out to do was to answer the questions that people very often ask me in chapter form. And I was approached, I didn't actually go out to write a book, although I had had a lifelong ambition of writing a book, but I thought it was going to be some elaborate novel. So when the chance came along, I was a little bit nervous. And then I thought, but I've got this stuff, it's here. And I really do want to tell the world about it. So the fun then was just thinking about how to chunk it up and to take different sections so that each chapter in a way sort of tapped into something really fascinating about human behavior. So things like time perception and altered perceptions and hallucinations and why drugs do what they do and how we communicate, and just really fundamental questions. I guess that's what I wanted to be able to answer, and to just do it in this really broad and hopefully appealing way.
And like, I won't feed the ego too much, because it is a very appealing book, and I know you've got some excellent feedback about it. But I do like that approach, like you say. Again, both of us have this link. We teach quite large, first-year modules at university, and it is those stories, those aspects of our work and our teaching that makes topics so interesting and engaging to people. And I absolutely get that link of what you're talking about. I talk to my students about this. I talk to my friends at the pub about this. And this is the stuff that people find interesting. Communicated well is so fascinating. And communicated poorly is those memories you've got of falling asleep in a lecture theatre that's probably too dark, too warm, with a too monotone voiced man standing there talking very slowly and patiently. And that's the opposite. But there is these things that this is the stuff I find cool, honestly.
Yeah, and one of the things I'm really passionate about is myth busting. So a huge number. So throughout the book, I have these myth busters, and I try to sort of tackle some of the ideas that people have that are based in no science at all. You know, the idea that we only use 10% of our brain power at any one point. I mean, those ideas have really taken hold, and myths around left and right side of the brain. I just wanted to present the science as I understood it and as I knew it, in a straightforward way, and a way that got to the bottom of what's real and what isn't real, or what has evidence and what doesn't have evidence.
So let's talk about some of those then, because today is International Women's Day. And if I was more organized, I would have recorded this 2 weeks ago. So we could have released this podcast today. Instead, we're recording it today, and I'm calling it kind of a tie. But one of the questions in the blurb for your book is, one of the reasons I wanted to have you on, is that real famous kind of prevalent idea that men and women are fundamentally different. And you have it here: are men and women's brains actually different? So, Professor Catherine Loveday, are men and women's brains actually different?
So I'm going to give you the long answer to that question. I want to first of all admit that I actually left this chapter till last to write. It's actually quite early on in the book, but I was really scared about writing it. I thought, this is such a controversial topic. It's really difficult to get it right. So I left it to the end. I procrastinated and put it off. And actually, when it came to writing it, I loved it. And it's one of my favorite chapters. And it's one that I very often go out and talk about at schools and things like that. Actually, not often on things like International Women's Day. And the answer is, men generally have bigger brains than women on average. But the actual differences are very, very small. And there is a huge, huge overlap. So and this is just talking about the size of the brain. Once we start to dig down to different structures, well, yes, it looks like there are certain structures that on average and across a huge number of people are slightly different in men to women. But just because you might have a hippocampus that's more male, you might have an amygdala that's more female, if you see what I mean. So each structure, was some fascinating work that came out a few years ago, where they showed that you could kind of effectively look at each different structure of the brain and say, this is the typical male amygdala, this is the typical female amygdala. But the key thing is, firstly, there's this massive overlap. Secondly, you don't necessarily have male structures that are all the same, or female structures that are all the same. And then there are lots of additional problems. So even if we acknowledge that some of these differences are there, there's a big publishing bias. Science journals like to publish the differences. They're not so bothered about about publishing where there are no differences. So we have a bit of a publishing bias. And then there are two really kind of extra problems. One is that just even if we assumed that the brains were slightly different, even if that was true, and as we say, the overlap is tiny, even if that was true, the function does not necessarily follow. So even if my hippocampus is slightly different to yours, it doesn't mean that I remember differently to you. And the sort of overlap between structure and function is not as sort of strong as some people assume. And then we have probably the most fundamental thing, which is the nature-nurture problem. And as you know, and as many people understand now, that the brain is plastic. It's adaptable, it's flexible, it changes in response to our environment. And one of my favorite things to say to students when they come into like a learning and memory lecture is that when you leave this room, your brain will be physically different to the brain that came in. You don't just remember stuff by magic. It's not sort of written down in a little notebook in your head. Your brain physically changes in response to everything we learn, everything we hear, everything we do. And that adaptability and that flexibility and that changing of the brain means that we are so hugely a product of our environment. And so most of the research shows that once you strip back these kind of the sort of gendered world that we live in, you see very, very few differences. So even where those differences exist, you would have to get a baby at birth where the parents had not known to really be able to get that. And that research has largely sort of not been done. And there's a great example of this. This is my favorite example of this. So this is looking at sort of function of the brain rather than actual structure. But it was a study that was done where they gave boys and girls the same task to do. And it was a drawing task. They had to sort of copy a fairly elaborate drawing. And they told the girls, they told half of them it was a drawing task, and they told half of them it was a geometric mathematical task. Now, you can probably guess what happened, but when they told them it was a mathematical geometric task, the boys did better. When they told them it was a drawing artistic task, the girls did better. Exactly the same task, scored in exactly the same way, but whether you describe the task as a typically female task or a typically male task influenced how well people did on that task. So the point is that right the way along, we're bringing our history, we're bringing our world, we're bringing our expectations with us. So fundamentally, if you ask me that first question again, I would say, yes, there are some differences, but I may have a more typically male brain, you may have a more typically female brain, or I may have sort of different structures that are male and female in different ways. But even if all of that's true, it's partly because it's a product of our environment, and it doesn't necessarily mean that we would do things or think things or say things any differently. So that's my sort of long answer to your intriguing question.
I love it. I think it's a great answer. Do you think we could get to the point where you could separate out what the environmental differences were? Like, this is the puberty-induced sex hormone differences, without going too far into the physiology, and this is because we painted her room pink and gave her Barbies. Do you know what I mean?
Well, yeah, I think it's very, very hard to really get to the bottom of that, because so many of those environmental influences are quite subtle and we're not aware of them. So to strip them away completely is almost, well, I would say impossible, in fact. But there are ways, of course. I mean, you can either look at newborns, or you can, as you suggest, look at hormonal influences, which is a bit different to looking at brain structure differences. If we're looking at circulating hormones, then it's a bit easier to do that research, because you can look at what happens when someone has a higher level of testosterone or a higher level of estrogen. And of course, there are lots of examples where that happens naturally, like sort of the menstrual cycle or menopause, or even where there are various drug treatments that are given. So that can be explored more easily, the circulating hormones. What is less easy, and I would say it's almost impossible to look at, is the difference between nature and nurture, or the different impact of nature and nurture on the structure of the brain and on people's behavior.
Yeah, you can tell the physiologist, scientist, because I'm straight away, we'll just go to this model and just look at this drug and look at this research model of rats that have been over-optimized or whatever. But that's, like you say, almost impossible to strip out the environment and society, I'm sure. And yeah, this is something that I'm only learning about quite quickly at the moment. Those tiny, constant, chronic stimuli, I guess. Wow, so that's a big answer, but I like it. It's interesting. I'm going to pick up a few more from your blurb, if that's okay with you, because these are some of the big questions. One of the other ones you wrote, which I thought was such an intriguing question, and something I've read a little bit about as well, was the statement, what does it mean to be conscious, excuse me. Now that is one of those questions that, the kind of question you write down and sounds easy, and then you think about it and it gets worse and worse and worse. So
and that is sort of almost my answer, is because actually trying to define consciousness, no one can even agree completely on what a definition of consciousness is. So consciousness is so much a subjective thing. I can only assume that you're conscious, and we start getting into philosophy, and I'm much less comfortable with philosophy. What I'm more I suppose comfortable with is the biology. So I'm comfortable with the idea that there are certain manipulations you can do that can alter someone's conscious experience. For myself in particular, I'm quite interested in the difference between a conscious memory and a non-conscious memory. And so, for example, a conscious memory would be, I remember the conversation we had where we were chatting about exercise and the importance of exercise and the physiological effects. But maybe a non-conscious example of that might be that conversation, while I'm not thinking about it, could influence a decision that I make at some point in my life. Or I could be in a shop and I want to buy something and I think, oh, I'll get that, and I won't know why, but actually why is because of something that's previously happened in my life. So in fact, a huge amount of our memory system is non-conscious. We're not consciously reflecting on it, but it's affecting the way we behave and what we do. Advertising, of course, completely taps into that. So I'm sort of moving your question, I suppose, to an area of consciousness that I can study, but because I think we have looked for really intriguing ways that we can study the difference between someone's conscious and unconscious memory. We can measure that a previous experience has impacted on somebody, and we can look at what's happening in their brain without them having any conscious reference to it. And a great example of that, for example, is people with amnesia. So people who have really quite severe amnesia. I've worked with a lady for a long time who had an infection in her brain, and she has lost her memory for most of her life. So she's got 4 children. She doesn't remember any of them being born. She can't really remember anything much ever happening to her. She knows that stuff happened to her. She knows her history and she's learned the facts of her history, but she can't relive them in the way that you or I might. She can't think back to something that happened and reimagine herself in that place. And people who have that kind of amnesia, what's really intriguing is that they can have no conscious recollection of something, but their behavior shows that history is still shaping the way they respond. So they might still be scared about something and not know why it's making them fearful or scared. But their family can say, well, this thing happened to them in the past. And so their body and their mind has carried that unconscious memory of what's happened and is influencing the way they behave. And we can even look at this experimentally. We can give them tasks where we give them a memory list to learn and they can't remember the words. But you then use a sort of more subtle way of looking at physiological symptoms, physiological signs, and you can see that they are responding to those words and that they have made a difference and it has impacted on them. So those are the kind of experimental things that we can do. We can manipulate people's levels of consciousness, and we can look for patients that have lost certain aspects of conscious experience, and we can see what is different in their brains. And with memory, we know different parts of the brain are involved in conscious recollection compared to this sort of unconscious, instinctive sort of reaction that we might have to something without really knowing why.
That is genuinely mind-blowing. So I'm going to try and piece my brain and understanding back together after some aspects of that. So we have a conversation, I remember aspects of that conversation, and that's conscious memory. But you tell me something's healthy or something, and I don't remember why I make a decision, but that's unconsciously affecting future behavior, an unconscious memory. And those are stored, maintained somehow differently in our brains, therefore, because you give the example, that amazing example of your amnesia patient, who people who can change their behavior but don't remember or understand consciously what it was that's done that. That's fascinating.
And habit behavior, when we do things automatically, and a lot of what we describe as our procedural memories. So these are our memories for actions, like knowing how to walk and being able to ride a bicycle. You don't remember learning to ride a bicycle and you don't really know how you do it. And you don't think, when I'm on a bike, gosh, I've got to balance and I've got to do this and I've got to do that. That's just all stored and it just happens automatically. So it's really efficient for our memory system to put a load of this stuff into something that doesn't require us to reflect and consciously sort of give attention to it. So huge amounts of our functioning is based on memories that are stored and that we don't consciously access but are there. And sometimes we could consciously access them if we wanted to. I mean, I can sort of remember aspects of learning to ride a bike, but I don't think about them. I'm not consciously reflecting on it. It's just there. So, and you could say this for any aspect of cognition, that there are conscious elements, and then we have all this non-conscious stuff that influences how we behave. And it is so intriguing to start looking at brain imaging when that's going on, and looking at the different brain patterns that you see when someone's conscious of it compared to when they're not conscious of it. So it's a huge area. And I don't think we'll ever get quite to I don't believe we'll ever really understand what it means to be conscious, but it doesn't mean we can't really try and study what's going on in the brain in these conscious versus unconscious type experiences.
So now you mention it, you're right. I distinctly remember crashing a bike into a fence in my backyard when I still had the trainer wheels on the back of my bike. And I must have been 4 or 5. And I knew about pedaling, but I didn't know about braking yet. And that's when I learned that hills were bad. But so that, these are one of these conversations that make me sound even less articulate than I normally am, because I'm just trying to catch up with the ideas you're throwing at me. So that suggests all sorts of really cool things, but I guess the one that I'm going to try and drag us onto, so I sound like I know what I'm talking about, is you do a lot of work in almost queuing up memories to try and study people's memory. And specifically, you use music a lot. You mentioned at the start, you're a musician as well. We find out through these interviews that a lot of our academics are just amazing all around, not just academically. You've got the Beatles poster in the background, I see.
Yep.
That's a clue to your musical heritage. So how does music tie into our memory and awareness, and how does that tie into you?
Yeah, so I have always loved music. Music's always been an important part of my life. But as a psychologist and as a scientist and as a neuropsychologist, all of these things started really quite early in my career, started nagging me. Why is music so appealing? Why is it that so many people could not imagine a world without music? Why have we evolved to have this as such an important part of our life? I mean, I understand why we've evolved to speak and walk and eat and all of those things, but why have we evolved to have this real passionate love of music? And then as a memory scientist, why is it that those memories are so powerful? Why is it that you only need to hear a tiny bit of a song, or even just see the title of a song, to be completely thrown back to a particular moment in your life? And that's where I started, I guess. I started with my own love of music, with questioning why it was important. And then I started teaching the students and running a whole module on it. And that then kind of just got me thinking about it even more. And I have this absolute obsession with Radio 4's Desert Island Discs, because what you hear on that program is that people share really quite important moments in their life that have become attached to music. And we've been studying the Desert Island Disc Archive. It's an absolute joy to me that this stuff is all freely available. I haven't got to go and ask anybody anything. I can just sort of log into Radio 4 and I can look at their musical choices and I can ask, why have they made these choices? So, you know, take this situation. You've got 8 songs you can take to a desert island. You know, it seems like a fairly mundane question. What do people take and why? But actually, it's not mundane at all, because there's so many songs out there. People make choices for a particular reason. And some of those choices will be about how they look to the outside world, which in itself is interesting. But actually, we've repeated this experiment on people where they're not on radio, and we get very, very similar effects. And what we see is that people choose music that reminds them of all sorts of times in their life, usually really important times. They are most likely to choose music that reminds them of a person. Now, to me, that sounds, in some ways, one of the criticisms of psychology is that it's, often states the obvious. But actually, that's a really important finding, because if you put people on a desert island and say 4 out of 8 of their songs remind them of a person, they've taken those songs because it's a way of them having a connection with somebody else that they can take with them. It's a way of them really sort of being able to access their memories of that person and to feel like they're with them and to feel connected to them. And that has application, because lots of people do get separated. They don't necessarily go to a desert island, but they might go into a care home, or they might have to move to a different country, or they might be isolated and hospitalized, or many other ways in which people can get separated from their environment. And it seems that music is a really, really good way of people taking something of themselves in their relationships with them. The other key feature that we saw is that people take songs that remind them of something that's really important in their own life, usually what we call these self-defining memories. And these are memories that take people back to a key decision they made, or a key moment, something that really influenced who they became. And my favorite example of this is Bruce Springsteen, because 3 of the songs he took were about him choosing to become a guitarist. Now, Bruce Springsteen could have taken all his own songs. He could have taken any songs, but actually 3 of the songs he chose were like, one of them, for example, was when he heard I Want to Hold Your Hand by the Beatles. He heard that song and he said, God, I really want to be a musician. I want to be a guitarist. So he goes out and he buys a guitar and he becomes a guitarist. One of the songs he takes to the desert island is a song that reminds him of how he became himself and why he became himself. And so we believe that one of the reasons that these memories are so important is that they help to remind us of our identity and of who we are. The other thing that's really intriguing, and which is not that much of a surprise, and most people kind of recognize this as soon as you say this, is that people tend to choose songs from what we describe as the reminiscence bump, which is a period of time between the ages. I mean, it's been shown in other things, it's typically between 10 and 30, but for music, we see that it peaks around 15. So people choose songs from this time. And when you've asked them why they've chosen those songs, it's usually because of a lot of these self-defining moments, choices they made about who they wanted to be, where they want to live, who they want to spend their life with, what career they want to have, what their political views are. All of these things are wrapped up in those things. And I guess I'm interested in that just because it's interesting, but I'm interested in what's going on in the brain. Why does music wrap itself around our memories in this powerful way? And what is the value of that? How can we use that in a clinical setting? So yeah, and we do see some intriguing things when we look at the brain patterns. We see that older musical memories seem to be stored differently to newer musical memories, which is partly why music is so good at being remembered, even when people lose a lot of their other memory capacities. But it's such an intriguing area, and it's such a joy to research, because asking people about their favorite music just always generates brilliant conversations.
I like the term reminiscence bump. And like you said, and you introduced it, as soon as you say it, I go, yeah, you're right. Those kind of the music that I define as my teenage years are those that have the strongest association of memory for me. And I'm guessing if I had to pull something out for my top 8 tracks, which would take a lot of thought, it would be, at least that part of my life would be represented. Is it music specifically? Like, I'm thinking about other senses, like the ability of a dish to take me back to the place or the time, or lemon tangine for me will always be the Atlas Mountains, hiking to the Atlas Mountains. Being too cold for me will always be some very important years of my teenage years growing up in the north of Canada. So is music special, or is it a sensory thing for humans?
So it's a bit of both. So we do know that happens. You can cue these kinds of memories with all sorts of things. And there are some arguments that certain senses will take you back, are more likely to peak at different points in the life. I mean, most stuff tends to peak at the reminiscence, that typical 10 to 30 sort of age group. And there's a number of theories as to why that is. But there have been some suggestions that smell, for example, and taste might be a little bit earlier. And it may be that those senses develop a little bit earlier, or that there is a stronger connection to the memory system. But what we found in our research, so I worked with my PhD student, Amy Roy, we've done a whole series of experiments where we have tried to compare music to things like objects and photos and clothing, actually, which is a really interesting one. And what we see is that music is the most reliable for it, and it has the most powerful reminiscence bump, and it has the strongest levels of nostalgia. So we do still see that those patterns emerging with other types of stimuli, but music just seems to be particularly powerful. And it just, like, we've tried testing it in, I can't tell you how many different ways, and we always get the same effect. And the thing that intrigues me about music is that it's the memories associated with music, but it's also your memory for music. So if you give someone a memory test and you give them really tiny, tiny short clips of music, just so we do it with half a second of music, people will identify that music quicker if it's come from their teenage years, even if they don't like the music. And on the flip side, people have a preference for music from that time. So the two things are independent, whether you remember it and recognize it better, whether you prefer it, and then finally, what memories you have associated with music from that era. So it's just, it doesn't matter how you carve it up. Music seems to have a really sort of there's real longevity of music that we experience in that time. And the research seems to show that once we get to about 30, we will listen to other music. And some people are incredibly adventurous, and some people do choose music from later in their life. But it never seems to take hold in the same way from that age on. And that, I don't think, is so true. Like we see with photos, that often people will choose photos from much later in their life. So there's something about music where it has this peak and then it kind of dies back. But the other really intriguing thing is that that cascades backwards. So you see the picture of the Beatles in the background. Now, I was, the Beatles, I was born as the Beatles kind of recorded their last song. So it wasn't really part of my teenage years, but it's part of my parents' teenage years. And so I listen to it because they're listening to their reminiscence bump music. And so I then am listening to it when I'm a teenager because it's getting played in the car and it's being played around and so on. And then now my son is a massive Beatles fan. So 2 generations down, and you can see this in the data. So when you look at the data, you see a peak for your own period of time, and then you see a peak for your parents' reminiscence bump, and you even see a peak for your grandparents' reminiscence bump, which I think tells us something about how music is being transmitted down the generations and how we use it as a way to connect and bond with people.
That's so cool. I love the idea of there being like peaks and troughs in every 30-ish years in your reminiscence bump of music. That's so cool.
It is really great.
You almost hinted at it there, because I'm just mentally scratching off questions I have for you, because these answers are so interesting, and replacing them as we go. But you kind of hinted earlier at this, like, is there some sort of evolutionary reason why sound and music is so important? And then you hinted at there as some sort of complex social tool we use culturally. So is that part of the reason why you think music is so dominant in a human culture that relies on generational links? It provides us that link.
Yeah. So what I think, the reason, I mean, there are many reasons that music is probably important, and there have been many theories put forward. But if you ask me my opinion, I think it's because it taps into our fundamental emotion system. And so we have words, but the words without music have limited meaning. As we know, if we send a text message and it gets misunderstood, you haven't got the music around it. You've just got the words. And you can use emoticons, and you can use, all sorts of things to try and put it back. But fundamentally, what gives our words their meaning, their emotional content, is the melody, the pitch, the rhythm, the timbre, the characteristics of the voice. All of those things are what convey whether I'm happy, whether I'm sad, whether I'm interested, whether I'm bored. And so the emotional content comes from music. And even if you strip away words, we convey the most basic of emotions: screaming, laughter, crying, anguish. All of these are essentially pitch, rhythm, and timbre. They are how we musically what we do with our voice musically. And so I think that what music does is that it taps into that fundamental emotional communication system. And that is why we connect with it so easily. We're primed to respond to music from the minute we're born. Before we understand words, the only way we can understand what our parents are saying to us is through the pitch and rhythm and timbre of their voice. And right the way through our life, it still becomes how we read people, how we understand them. So I think we are primed to respond, to give attention to musical signals and to respond emotionally to them. And that's why I think that's my kind of philosophical reason for why I think we have evolved to have such a passionate relationship with music.
Yeah, fair enough. And is that why so much of your research into memory recall and aging, when we start to suffer the effects of cognitive decline and loss of memory, is that such powerful cueing factor from that reminiscent bump era music? That's what your work is about, right?
Yeah. So I think one of the things that we found about, I did my PhD looking at memory and aging and trying to understand how memory changes as we get older in a healthy capacity, someone who's healthy. And actually, one of the things that I found very early on has more recently been accepted as being a sort of more genuine finding, in a sense. They didn't seem to believe it from a 21-year-old PhD student, and it's the idea that actually memory doesn't get that much worse for healthy older people. It just gets a bit slower. So we have a bit less control over our memory. We can't necessarily access things exactly when we want them, and we take a little bit longer. But actually, people's memory, it doesn't get as much worse as people think. However, it does sort of tail off a little bit. And of course, what's more important are people that lose their memory pathologically. So there are a lot of people who lose more memory than would be expected in a healthy person. And because of what I've just been saying about how music links us with our fundamental self and with the decisions that we have made in our life to become who we are, if you lose access to those memories, and I see people where this has happened, obviously, it has a profound impact on you. If you can no longer remember why you chose to become a scientist, why you chose to work at the University of Westminster, why you chose to do anything, if you can't remember those decisions, you lose something of you. And so one of the things that I think music does really powerfully is to cue those memories back again. It's to cue those memories that remind you of who you are and why you became you, and to cue memories of that adolescent period, which is utterly crucial to those changes those decisions we make. And so I am really, really interested in using music to help older people, particularly those with pathological memory loss, to connect with those memories that make them who they are, and give them a sense of foundation.
There's I just happened to finish reading Adam Kay's book, This Is Going to Hurt, which those who haven't had a chance in the audience is a book about a junior doctor describing the first 6 years of his life. And there's a point he comes back to a lot about, as a 16-year-old deciding to become a doctor or not, because in the UK's education system, you have to decide kind of that young.
Yeah.
So those are such formative years for so many people, I guess. And I think I can understand where you're coming from, essentially. Going full circle to losing that unconscious, what do we call it? I've forgotten the word, unfortunately, unconscious memory about who I am, which must be difficult, So we're going to talk way too much, and this is the kind of conversation we're going to stop recording and then keep talking for another hour after, which is what I'm worried about. But the one specific question I wanted to make sure we got a chance to mention was what next? Because you're an active researcher, you're still working, you're still doing a lot of work. We've talked a lot about what you have done, but where are you taking it? What's next for you in your work?
Well, one of my problems is that I always have way too many ideas and not enough time, but maybe that's just what it's like for all of us. And I find it really hard to pin things down, but I think I guess that there are sort of two strands to my research that are really important. So there's the theoretical strand, there's understanding how memories are formed in the brain, what disrupts the memories, which parts of the brain are active when we remember different types of things. So and why those memories are so powerful. You know, there are a number of theories. I'd like to get to the bottom of those theories as to why those older memories are so powerful. But I'm also really interested in the practical application of this thing. And one of the things that I've learned is that listening to people talking about their favorite music immediately connects me to them. It doesn't matter whether I like the music they choose or not. You could tell me about a song that you like, and I might hate the piece of music, but actually, once you start telling me the story behind it, I think it immediately gives me some insight into you, and you start to see a common humanity. And this is something that is true of autobiographical memory overall. The more we listen to people's stories, the more we hear people's stories, the more we notice this common ground. And I think there's far too much divisiveness in our lives, in the world. Social media increases divisiveness. And I think there is a real capacity for this kind of autobiographical memory research to connect people. And what I think is really fascinating about music is that if we hear music we don't like, it can really kind of push us away. I can think, God, I really don't like that person because they're playing music that I don't like. So music has the capacity to connect, but also to make us feel disconnected from people, in the same way that if people are laughing about a joke and you're not part of it, it can exclude you. But if we can get beyond that, and if we say, we can ask somebody, why is that song important to you? Why do you like it? What is it that it's reminding you of? Or even, you know, these favorite dishes that you talk about. You know, if I'm to ask you about that particular dish and what happened, I might not like the food, but if I hear the story behind it, I'm immediately seeing a bit of Brad, and I'm sort of learning more about you. And I really think that that is the answer to us all getting on better, and to having a more better equality, better understanding of each other. I don't know, maybe in my kind of wildest dreams, fewer wars, but certainly fewer arguments, is by listening. And I talk a lot. It's my job to talk a lot, but I also love to listen. I love to hear people's stories. And people's stories surprise me. Right from when I started my PhD, I heard things about people that made me sit up in my chair and go, wow, this person has done some really, really fascinating stuff, or they've made really interesting decisions, or they've had a really hard time, or they've had a really amazing time. But you can't not connect to people when you hear those stories. You can't not be intrigued. At least that's what I think. Maybe I'm on my own with it, but that's what I think. And so I think what I'm interested in doing is continuing with the theoretical investigation, but looking at how we can use memories to connect people better.
That is lovely, wonderful, aspirational, ambitious, and probably the perfect place to end, unfortunately. I try and target half an hour for these, and I'm going to leave it in the recording, but we've blown past that, and that's fine, because this is such an interesting conversation. Unfortunately, that probably is about all we have time for today, or as I've mentioned, we've already blown past our time for today. So it only really remains for me to say thank you very much, Professor Catherine Loveday, for being with us today. If you've enjoyed today's podcast, feel free to subscribe, whether or not you're watching us on YouTube or listening into the audio version on iTunes, on Spotify, on Anchor, or wherever else you've found us. My name's Dr. Brad Elliott, and this has been today's Different Conversation.